Hi everyone, welcome to the channel. In this video, I will be going to discuss about chapter on real numbers. This video is part of 5 CBSE Standard 10 Mathematics. In this video, I will cover exercise 1.2. All the problems in exercise 1.2 clearly and detailed explanation I will give in this video. Get started. Some important notes which is required for the solving the problem of exercise 1.2. First, if p divides a square, then p divides a, where a is a positive integer. P divides the square of the number, also divide the number. 3 divide 27 square, 3 divide 27. Then theory by contradiction. At a time, only statement or opposite statement is true. Either statement or opposite statement is true only. If statement is true, then opposite statement is false, and opposite statement is true, then statement is false. Statement, opposite statement. X is positive integer, opposite statement, X is negative integer. At a time, any one statement is true. If X is positive integer is true, then X is negative integer is false. If X is negative integer is true, then X is positive integer is false. This is theory by contradiction. And coprime. If two numbers have no common factor except one is coprime. 9 and 14, the factors 1 and 3. 14, 1, 2, 7. 9 and 14, no common factor except 1. Then 9 and 40 is coprime. 12. 12 and 9. 3 is the common factor also. So 9 and 12 is not coprime. This is a coprime. In fraction, divide both numerator and denominator by highest common factor of numerator and denominator. Then the fraction is become coprime fraction. 15 upon 25, 15 and 25 is not a coprime. This can change into coprime fraction. 5 is the highest common factor of 15 and 25. Divide in both numerator and denominator. 15 upon 5, 3, 25 upon 5. 5 and 3 and 5 is coprime. 15, 25 not a coprime. Divide highest common factor of both the numerator and denominator, then get a coprime fractions. Then first question, prove that root of 5 is rational. This theorem by proved by using theory by contradiction. First contradictory. Let's assume that root of 5 is rational. If root of 5 is rational, can written in the form of R upon S. Suppose R and S is not prime, divide highest common factor of R and S in both numerator and denominator. Now get root of 5 is A upon B, where A and B are coprime. Multiply B root of 5 is equal to A, squaring on both sides. B root of 5 whole square is equal to A square. Square and square root cancel. Then 5B square is equal to A square. Left hand side 5, right hand side A square. Here 5 divides A square and also divides A. Here P divides A square, then P divides A. 3 divides 27 square, 3 divides 27. 5 divides A square and also divides A. So A is the 5 is one factor of A. So it can return 5C. Put in equation 2, 5b square is equal to 5c whole square. 5 square 25, 25 divided 5 is equal to 5c square. Now right hand side 5, left hand side b square means 5 divides b square and also divides b. Then in one size A and B are coprime. Coprime means A and B have only common factor 1 only. But 3 and 4, 5 is common factor of both A and B. 1 gives A and B have no common factor except 1, but 3 and 4 gives A and B have common factor 5. This is contradictory due to wrong assumption since root of 5 is irrational. Prove that 3 plus 2 root of 5 is irrational. So first step, let us assume that 3 plus 2 root of 5 is rational. Then 3 plus 2 root of 5 A upon B, A and B is coprime, B not equal to 0. Then in this type of question, one side keep only rational form, another side all rational numbers. One side keep rational number. Here root 5 is irrational. keep in one side, and 3, 2 is rational, transpose to another side. So 3 transpose A upon B minus 3 is equal to root 5. Divide 2 1 by 2 into A upon B minus 3 is equal to root. So left hand side 1 by 2 A upon B minus 3 is equal to root 5. Since A and B are integers, 1 upon 2 A upon B minus 3 is rational, and so root 5 is irrational. But this contradicts the fact that 3 plus 2 root 5 is rational. Here left hand side is rational, right hand side is irrational, which is contradictory due to wrong assumption. So 3 plus 2 root 5 is irrational. Third question, prove that the following are irrational. 1 by root 2. Solution, let us assume that 1 by root 2 is rational. 1 by root 2 is equal to A upon B. A and B is cooperant. B not equal to 0. Then transpose B upon A is equal to root 2. Since A and B are integers, B upon A is rational. And so root 2 is irrational. But this is contradict the fact that 1 by root 2 is irrational. First assumption is wrong. Here left hand side is rational, right hand side is irrational. This is contradict due to wrong assumption. 1 by root 2 is irrational. Irrational is wrong assumption. 1 by root 2 is rational. Second question, 7 root 5 is irrational. Let us assume that 7 root 5 is rational. 7 root 5 is equal to A upon B. A and B is cooperant. B not equal to 0. Then transpose right hand side root 5. Left hand side A upon 7B, A upon 7B, A and B is integers, so A upon 7B is rational, root 5 is rational. Left hand side rational, right hand side irrational, which is contradictory due to wrong assumption. Then 7 root 5 is irrational. 6 plus root 2 solution, let us assume that 6 plus root 2 is rational. If rational, 6 plus root 2 is equal to A upon B, A and B is coprime, B not equal to 0. 6 transpose to one side, A upon B minus 6 is equal to root 2. Here left hand side, A upon B minus 6 is rational, right hand side is irrational. So which is contradictory due to wrong assumption. Then 6 plus root 2 is rational. So here over all the problems in exercise 1.2. Thank you for